Alright, another draft physics video. Try to make it quick. Holiday has made a video, and again, just his titles are just horrible. So it states, irrefutable wave nature of light equals it adds and subtracts minus interferometry. But I mean, put the word irrefutable in capital letters for what reason? And to say wave nature, not seems like, which is his argument. Oh, it seems like a wave. It seems like it should be. It seems, but he's making the argument that he still thinks light is a particle. I don't know in what form he thinks it, whether he thinks it in the same form I think it's a particle, which is a photon is the measurement of a quanta. So anything we call a photon would be actually more than one ton element. And that the photons themselves do not come in the ton parts, the quanta, do not come in sizes. So maybe his perception of it is a red light is a big fat one and a blue one is a little one. Maybe that's the way he sees it. Where I'm arguing, no, they're all exactly the same size. The only thing that changes is the red ones are farther apart than the blue ones. But it's all the same stuff that it's made out of. So these would be the particulate nature, the elemental nature. And again, but he doesn't elaborate. So anyway, let's go to the videotape. The video. We're not going to play the video. We'll just use his graphic. So he's describing a laser experiment that he plays later. But this description, he's left out quite a few elements. The lenses, for starters. So this experiment was done with a change from tradition, in the sense that most of the laser experiments, the MIT ones, they're very good. I'll jump back. See, the two spots are actually showing up. He's implying that when this one's on, this one's off, and that's not really true. They're often both on, and are both off. So that's sort of a giveaway that this isn't what it's being sold sort of as, some sort of paradox or problem. So we have, in the real experiment, we have a laser, we have a lens right here. So both sources, before it gets to the interferometer, it goes through this lens. And this lens is basically got an aperture in it, and it's creating Newton's rings. So this is a ringed pattern going into the interferometer. And we have two lenses here for these displays. And those lenses are basically saying, I don't want to see Newton's rings. I just want to see the center dot. And so these are just narrowing it to just the center dot. And that takes a lot of the mystery out of this thing when you add the complete story. So anyway, his drawing doesn't have lenses here, and he doesn't have the lens here, the important one. So anyway, the laser is being Newton ringed. So this is a ringed pattern coming out. And it goes into this beam splitter. Now everybody just says, oh, beam splitters just split light, that's all they do. And that's not all they do. And it's really important to understand that's not all they do. So I guess I could just draw it as a pattern of dots and leave it at that. But what a beam splitter is, the kind in this experiment especially, is just half mirrored glass. So this doesn't even represent the truth. The real truth would be these are half the space is mirrored, half the space is empty. And what that, I think, there can't be denial. This is a diffraction grating. It basically means that there's holes, empty holes, in space. And those holes are essentially the multi-slit experiment. It's going to, the light is going to be spread and diffused. Yeah, in a sense. So it's just important to understand that when the light goes into this mirror, okay, the light that goes through, alright, so let's say it goes in as a beam. Well, we know from what I just explained, it's going in as Newton's rings. And when it goes through, what's happening is it's going through a diffraction gradient. And so what's going to happen is it's going to spread going through, and it's going to be diffracted into strong and weak elements. It's going to be spread and broken into pieces. And then when it reflects off the mirror, it's going to continue to spread by the rules of refraction. And so in this example, you could sort of understand that the light that goes through the first time is spread and then spread again and then reflects. So its spread path is twice this distance. The light that reflects, so that's an important thing to say here, is the light that reflects doesn't get spread. The reflection is straight, coherent. So the light that goes through gets diffused, spread. The light that reflects stays straight and narrow. So the light that takes this reflective path is fine, and it doesn't diffuse till it gets to here. So this one has had this whole distance spreading versus this one just this distance. So in a sense you could understand that as being the two lights that are getting mixed are essentially this and one that starts way back here and goes here. So those are the two that end up at the target, at the screen. This is what's being mixed, essentially. So the two sources of light now have been fundamentally changed, not just minorly changed. This one still probably has some semblance of its Newton's rings intact, but who knows how much. But obviously this one would have them spread much wider, a whole different kind of pattern. And those two patterns are the ones getting mixed, so to speak. And we say mixed, and I say it guardedly, because what's being mixed is the energy. So I would argue that, okay, so these waves are in phase in a sense. Okay, that every third photon or so, these two will match, the infrared and the ultraviolet. If they initiate them at a certain point, there'll be a certain phases where they'll both be on and they'll both be off if you're mixing two kinds of frequency light. But it's really important to understand that these lasers don't necessarily produce light in perfect phase. So even though it's the same wavelength light, the wavelengths can be off in the mixture of the light. So that's important. Unless it's a pulsed laser, it's difficult not to have mixtures of phase in the light you're actually shooting. So these two wouldn't have the same necessarily. The light getting reflected doesn't necessarily have the same phase. But we don't know what this piece of this splitter is actually doing in terms of filtering what goes these two directions. What light is, how it's polarized, or a lot of other issues that they don't go into. So you don't even know what you're getting going one way versus what's going the other way. Now the real question is, let's say I'm correct, and you have these two different beams now. One is spread, one is not spread, and they come into this piece of glass to be mixed, essentially. Now, I guess by pyrotype logic, they think the mixing happens here, that somehow these two waves spread out and they mix in space here and do their interfering or their non-interfering. So the important thing I wanted to, the important point to make here is that the beam they're looking at is just the center of the Newton's rings. So all they're doing is seeing what phase it is, on or on the off phase. But when when the spot in the center is empty, or the spot in the center is dark, it just means the ring order is different. So this means that the first ring is dark, okay, on this one, and the first ring on this one is light, and then so on and so on. And this one's empty, and this one's now dark. So all we're really talking about is this phase difference. Now what's not shown in the laser experiment is they're not seeing all this light, this outside light. They're just looking at the two dots, and that's what they're turning on and off. But the light's still there, they're just not recovering the on part. They're not seeing it because they've narrowed the focus to just look at the dots, the centers. That's really important. Alright, so my argument is that what happens is where these two beams are combined is in the structure of this mechanism. So I would argue that the energy, as it's being combined, the two now different beams, one diffracted, one not diffracted, and one is now going to be diffracted as it goes through the medium, and the other one's going to just be reflected. Well, my argument would be is that when there's a whole argument about exactly what happens in reflection and refraction, that the photon that goes in isn't actually the photon that comes out. And I think that's especially understood with refraction. So the light that goes through is not the same photon. The photon interacts with the electrons in the substance and then leaves. And I think that's sort of been proven by the fact that they can change polarization of light by applying energy to a medium. So you can put light through like oil and then put magnetism around it, and you can change the polarization of the light because you're basically changing this. You're fucking with the electrons. The light is being pushed through. It's being transferred through. And the light being reflected, so this is the light going through, and the light being reflected is also imposing energy. So when it goes, a reflection causes an equal but opposite reaction inside whatever it's reflecting off of. So the reflected light that's going here, both of these are energy. Both of them are going to convey energy as they pass through. So the 40% slower the light goes when it goes through a medium, that 40% is essentially time, and that time equals energy. Okay, the amount of time the light is delayed is a constant. The whole time you're pushing light through, there's a certain amount of light that sort of stays in the glass, so to speak. It will be released later, but I just mean the delay means it stays in the glass. So the glass is essentially, it's been energized. It's been, I don't know what the right word for it is, but it's almost like a laser. It's been pumped. You've essentially pumped the electrons when you're shooting reflections off of glass. You're pumping the glass, and the same is true when you're transmitting energy through glass. You're pumping the glass. Now, whether the glass lasers or amplifies, well, I'm not making that argument. But the truth is, you're pumping the electrons. And the effect of that pumping, okay, is going to be based on the phase, the energy going in. So, where you have the photons are in phase, then you're going to have a photon coming in for the reflection and the one going through the transmission are going to be in phase. But the problem is the transmission, like I said, takes 40% longer. So their phase shift is inevitable in the sense that the energy that goes in, and, the peak hit, may be affecting the medium at a different rate than the light being transmitted through it. But, I would argue that there probably is some connection between the phases. But what's really messed up the phases is the fact that you've spread the light, and in spreading the light, so another point to make, is in spreading the light, you've changed the distance the light travels. And so you've automatically changed the phase of the light that has been spread by that distance. So we're back to the sine theta thing of the two-slit experiment. So for the more pitch, the more you spread the light, the more time difference you're creating in when this is peak versus when this is peak. And you'll get a whole wavelength behind as you get further and further away, and it goes through the half wavelengths first, but that's what's really happening, is you're spreading the light. And that's changing the phase of the light, and changing the phase at which it hits the mirror, and therefore changes when the glass is energized and when it's de-energized. So I'm going to argue that everything that happens inside the interferometer in terms of the mixing of these two beams, that nothing happens out here. There's no wave interference. The interference is an impact interference, and it happens in this medium. Yeah, so I don't know if I have to say that much more about this. You can clearly see, if you watch Hosladay's video, I mean, if you've watched, I've watched all the MIT laser videos. They're quite instructive and interesting. And if you watch it, he moves this closer to get these two to equal length. Well, he claims it's equal length, but all he's really doing when he moves this closer is making the rings. The rings start off fine, really fine rings, lots of rings, and he's really just making the rings incredibly thick. So now it gets easier and easier to isolate this middle. And that's really what's happening, is he's getting rid of all the periphery rings aren't being reflected into the beam, so you don't see them anymore. So let's just point out again that there's no absolute consistency in terms of the on-off. That's not showing the videos. The video is fucked-hearted. So one light's on there. Let's see if we can have two on again. Alright, so there's two on. And it technically just basically said, well, it should be one on, one off, and no, it's nothing like that. There's 1 1/4. Yeah, too much crap in the way here. So now he's moved the mirror back, and the rings show up. So which all you're really seeing is, before you were just seeing the centers, and now you're seeing that no, all that's really happened is the phases are different. So one path is giving you a longer I don't know how to put it the right way. When he presses on this and changes the distance of one of these, it's just changing the distance of how much these two things are off. Again, remember, one of them is spread, and so it just changes how much this angle can matter. This angle matters less the more as you change the distance. But this is what really is causing the interference, is the two beams are been fundamentally changed. By one is much more spread than the other one is, and the interferometer just gets rid of all of that and just understands the light as being impacts. So it's taking, you could argue that this isn't going to be seen because it spreads, so it's taking this and either enhancing or destroying based on how strong these rings are and when they show up. I guess it'd be one way to say it. But anyway, lots of refutability here. I just don't see any point in saying something like irrefutable wave nature. There's nothing irrefutable about the whole wave concept, because the pattern is on off. The pattern isn't sophisticated enough to be able to narrow it to one cause. There's lots of ways you can create on off. Anyway, alright, probably enough. But anyway, these are experiments I'm going to do. Because they really aren't out there. I went looking around, and I said nobody plays with the interferometers. So I don't have to create an interferometer. I think I just have to create a diffraction gradient with a medium like glass, and see what happens if I shoot radiation at the interferometer, even through the middle of it. I'm theorizing that I can change the pattern. So I can take an external source, another source of light, shoot it into an interferometer, and screw up what it does this way. That's my prediction. You should be able to fuck with it. I think you can. But we'll find out. Yeah. I think these are experiments I can do. So I'm going to try to do them. Okay, so until next time, such.